Welcome to the night class. This is Coach Knight. Once again, today we are going to do a little graphing. We're going to graph sine and cosine. And this is just the basic graphs. Okay, so nothing too hard. Let me just say it like that, hard. Okay, went too far. Okay, so at first, let me start by showing you kind of what you're doing. This is a coordinate plane, yes. Okay, everybody know you got the x-axis and you got the y-axis. Okay, we've been putting a circle, right? Let me draw a separate one right here.
Is this test Friday?
No, man. Next week. All right. So you've been having a circle, right, with quadrants. Okay. How many quadrants are there? Four. Keep that in mind. Okay. And we've been talking about it. Each quadrant has reference angles, right? Okay. So there's a 30-degree angle in quadrant 1, right? And there's a 30-degree angle in quadrant 2, which would be 150. There's a 30-degree angle in quadrant 3, which would be the same as 210. And there's a 30-degree angle in quadrant 4, which would be like 330. Everybody with me there, okay? So what we have done here is we have taken our circle and cut it, okay? And rolled it out, all right? And this is what happens when you take the sine of whatever angle you're talking about, okay? So, for example, the sine of 30 degrees, okay, if you notice, you have pi over 2, 3 pi over 2. What is this point right here? Pi. And this one is 2 pi. That's one full circle. Everybody with me? The sine of 30 degrees, notice, see the 150 right here? And the 300? Everybody see that? That's degrees. These are radians. All right? So each of these, 30, 60, 90, 120, 150, each line is going 30 degrees. And they also have the radians on there at the same time. So you can kind of look at them at the same time. All right? What is the sine of 30 degrees? What is the sine of 30 degrees? 1/2. Okay? That makes sense? The sine of 90 degrees would be? No? Where is it? 0. Okay? I'm sorry. Not 90 degrees. There's 90 degrees. My bad. Sine of 90 degrees is 1. Okay? Which is pi over 2. The sine of 180 degrees, or pi, is 0. Okay? And it keeps going. The sine of 270, remember in quadrant, what? Where is sine negative? What two quadrants? All-star trig class. What two quadrants is sine negative? Third and fourth quadrant. So notice, here's the sine graph, and between 180 and 360, what is sine? It's negative. It's down here at the bottom. Okay? It's positive up here at the top. This would be, just to show you, that's quadrant 1. There's quadrant 2. Here's quadrant 3. And there's quadrant 4. Is that making sense? Okay? So, your graph keeps doing this. And it keeps going over and over and over. Because once it gets back to 360, what happens? It just starts over, right? Okay? So this is keeps going over and over and over. It never stops. Every time I show this, people always ask, when will we ever use this? Graphic designers use this all the time, because if anybody ever play that old game, Galaga or whatever, where they come, you're shooting and they come in all a little different. Okay, they're making them move using trig equations. Okay, so if you want if you want, say, a hot air balloon, you have some game that has a hot air balloon, and you want the hot air balloon to go up and down and up and down, okay? They're coding sine of something into the code to make it do that. Is that making sense? Okay, yeah, seriously. Wow. All right. So here are the characteristics or the properties of, oops, I went too far. The properties of the sine graph. Now, the properties of the sine graph and the properties of the cosine graph are very similar. They have lots in common. Went way too far. Here we go. The period, okay? The period is how long does it take to start over again, okay? So in this case, if I started here, right, one full wavelength all the way around back to the beginning is how long? 360 or 2 pi, okay? So that's what's called the period. What's one complete wavelength is the period, okay? Morning.
This is beautiful.
It really is. All right,
You're not
the domain, all right?
We're gonna have to try again next week.
Domain is what x can be, right? What can x be here? How far does it go right?
2 pi.
Nope.
Forever.
It just stopped. It goes what? You said it.
Forever.
Forever. It goes forever to the right. How far does it go left?
Forever.
Forever. So my domain can be all real numbers. Okay? Is my range all real numbers?
No.
No. How high does it go up?
1.
1, and it goes down to
-1.
-1. So my range is between -1 and 1. Everybody with me? Okay? And again, this is just your basic y equals sine of x. All of this stuff can change by changing the equation, right? This is the parent graph. Okay, now when you started doing quadratics, you just started with y equals just x squared. Okay? This is just the beginning. Okay? So all of this stuff can change, but for today, it's just sine of x or just cosine of x. Okay, we're just doing the parent graph today. All right, it tells you the x-intercepts are located at pi times n. Okay, so when I say, hey, the x-intercepts are at the pi's, that's what I'm meaning. The x-intercepts is crossing the x-axis at 0 pi, 1 pi, 2 pi, 3 pi, 4 pi. Okay, its maximums. Okay. It says the maximum values are y equals 1 and where x equals pi over 2 plus 2 pi n, where n is an integer. All right. That to me is hard to understand. Okay. Here's how I keep it straight. This right here is 0 pi, correct? All right. This right here is 1 pi. There's 2 pi. The next one would be 3 pi. If you're coming after an even pi, so 0 pi, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. If it's the next one after it, it will be a maximum. Okay? If it's after an odd pi, it will be a what? It'll be a minimum. Okay? Everybody with me? Now, can that change? Yeah. Okay? If you put a negative out front, guess what? That flips. Okay? All right? But just for now, if it comes after an odd pi, it's going to be a maximum. If it comes after an, excuse me, I said that wrong. If it comes after an even pi, it will be a maximum. If it comes after an odd pi, it is a minimum. Okay? It's crossing the y-axis at what? 0. Y-intercept is 0. And like I said, we talked about the maximum and minimum values. Okay? All the cosine does is takes this and translates it over a little bit. Okay, so we're going to do the same thing with cosine. There's the cosine one. If I go to, don't go too far. I knew it. Okay, so there's the properties of cosine. But notice, here's where it was on sine, okay? But it was crossing at 0, right? So it's just basically been shifted over 90 degrees. So now, period's the same period. Domain's the same. Range is the same. All that's the same. 1, 2, and 3 are the same. Here's what's different. The x-intercepts are now different. Instead of crossing at the pi's, where are we crossing at? pi over 2, 3 pi over 2. Where do you think the next is going to be? 1 pi over 2, 3 pi over 2, 5 pi over 2, then 7 pi over 2, then 9 pi over 2. Okay? So I say the x-intercepts are at the pi over 2s for cosine. Okay? All right? The y-intercept for sine was at 0. For cosine, it's at 1. Yes, ma'am.
Virginia Herald.
I sure do.
Please sit in this heart for a moment.
All right. So, at Miss Guidance Office. At cosine, your y-intercept is 1. Sine, your y-intercept is 0. Okay? And to be honest, the way I show you, it's pretty simple how to graph it. Okay? You just have to remember the pattern, because does the pattern change? No, the pattern stays the same. Okay? It's going up, down, up, down. It's just, okay? It keeps going. So, all you have to remember, you remember how on the sine, your maximums were after the even pi's and your minimums were after the odd pi's, okay? On cosine, your maximum is the even pi's and your minimum is the odd pi's. So notice at 0 pi, it's a what? It's at the top. It's a maximum. At 1 pi, it's down at the bottom. It's at the -1, so it's a minimum. At 2 pi, it's a maximum, okay? So all you have to do is keep straight is, all right, sine goes through 0, goes through the origin, and it has maximums at the after the even pi's and minimums after the odd pi's. Cosine goes through 1 on the y-axis, and it has maximum at the even pi's and minimums at the odd pi's. Okay? So, let's do one, because this is kind of hard to do without just trying it. All right? It says, graph y equals cosine x, and it gives you the interval. It says from 5 pi to 7 pi. How far is it from 5 pi to 7 pi? 2 pi's, right? So that we're graphing one full period. Okay? So here's what I'm going to do. I'm going to make my little... You're making an XY chart, but it's kind of different than what you're used to. Because really, do we have to go very far high? No. Okay, what's the highest it's going to go? 1 and -1. Okay? And I'm going to use, rather than counting all the way to 5, I'm going to use this little, it looks kind of like a little lightning bolt. Do y'all know what that is? Know what it's called?
Heart rate.
Heart rate, good. We call that in the graphing world a break. Okay, and basically that means you're just skipping a bunch. Okay? Okay, so if you see this, you're skipping a whole bunch, and we're going to start at 5 pi. Okay? Where are we going to end at? 7 pi. Well, what's halfway between 5 pi and 7 pi? 6 pi. And then we got to do these in the middle. Now, this usually gives people a hard time, okay? But it shouldn't. Watch how easy this is, okay? What's 5 plus 6? 11. This is 11 pi over 2. Because it's halfway. This is, look, 5 pi, right? I'm going to write it out. 5 pi is 10 pi over 2, right? 10 pi divided by 2 would be 5 pi. 6 pi is 12 pi over 2. And so what comes in between them? 11 pi over 2. Okay? Can everybody do that?
Why can't it just be 5.52? I mean 5.5 pi.
Right. It would be 5.5 pi, but they don't want you to write it as a decimal. Okay? It would be 11 pi over 2. Ma'am?
Is it because like we're halfway to 11?
Correct.
So are we?
This is 5 pi is the same 10 pi. Oops. 10 pi over 2 equals 5 pi. Okay? 6 pi, or excuse me, 12 pi over 2 is 6 pi. And we're going halfway between 5 pi and 6 pi. So what's halfway between 10 and 12?
11.
What's halfway between 10 and 12? 11. So this is 11 pi over 2.
But are we trying to get to those numbers? Is that why we're doing half?
Correct.
So we're trying to get to 11.
We're trying to get halfway between 5 pi and 6 pi. We're not trying to get to anywhere specific number.
It's really just 5 times 2. And what's 5.5 times 2? Then that's what you write.
No,
That's simple.
I don't understand why we're doing that. Like, why can't we just write 5? Like, are we trying to get to a certain number? Is that why we're doing 11?
We're getting halfway.
To 11.
Halfway between 5 and 6. This is 12 pi, right? What would 7 pi be over 2?
14.
So in between there would be what? 13 pi over 2. We're reducing, okay? We don't write 12 pi over 2 because 12 over 2 is 6. We reduce it to 6. You follow me? We write 7 pi. We don't write 14 pi over 2 because 14 pi over 2 is 7. So in between 12 and 14 is 13 pi over 2. Okay? We're just writing halfway. That's all we're doing. And the easy way to do it is you just say 6 plus 7 is what? 13. 13 pi over 2. Okay? If it were 7 and 8, what would it be? 7 plus 8 is 15 pi over 2. All right? If it's 20 and 21, it's going to be... Oh, wait, I did that wrong. No, I didn't. No, I didn't. It's 41 over 2. All right? It's just hard. It's just big. All right? So, no big deal. You're just adding these up, dividing them by 2. Okay? Because, why are we dividing by 2? Because we're finding halfway. Okay? Every time you do these, how many quadrants were there in a circle? How many? 4. You want to break up your line into fourths. Okay? Every time. Everybody with me so far? Okay. So, this is cosine. So you have to remember the properties. Where am I crossing the x-axis for a cosine?
1.
No, the x-axis, not the y-axis. I see. I'm not even touching the y-axis on this one. I'm going from 5 pi to 7 pi. So look, you can look back at your notes if you need to. At the pi over 2's, correct? On the cosine. So I'm crossing x here and there.
All
right.
That's why you want it like that.
Yes. Now, at the odd pi's, am I a maximum or am I a minimum? I am a minimum. So I come down here at 5 pi, it's an odd. I make it down at -1. 6 pi is an even pi, so it's a what? It's a maximum, so I come up here to the top. And then 7 pi is odd again. It will be down here at the bottom. And then you connect the dots with a nice little smooth little curve, okay? As smooth as you can be. Boop. Looks like a little bell or a little hill. Now, can you get more points? Yeah, you can, but those are really the only ones you need, okay? You know it's doing that every time. Everybody good? 10, okay? 10 is the same thing, but it's sine, and we have a different interval, okay? Oops, wrong way. Come on. There we go. So sine, again, I'm going to draw my graph. Notice, what's my interval this time? -4 pi to -2 pi. So this time I'm going the other direction, okay? I'm going this way. What's the highest point it's going to be? 1. -1. I'll make my little break. Boop. I'm going to start at -2 pi. And I'm going to end at what? -4 pi. And I break that into 4 equal parts. Okay? What's halfway between -2 pi and -4 pi? -3 pi. Okay? I almost put over 2, but it's not over anything. Okay? What comes in between -3 pi and -2 pi?
5 pi over 2.
Negative 5 pi over 2. And again, I'm just getting that by adding -3 and -2. Everybody with me? What comes in between -3 pi and -4 pi? -7 pi over 2. Okay? And then you just make your dots. So this one is sine. Okay? Sine crosses x-axis where?
At the worst.
At the pi's. Okay? 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. Okay? So at -4 pi, it's crossing x. At -3 pi, it's crossing x. And at -2 pi, it's crossing x. Okay? Always remember you're reading it from left to right. So after the even pi's, it will be a maximum or minimum? A maximum. So -4, is that even or odd? That is even. So I'll come up here to the top. Boom. Here, -3 is an odd. So after -3, it will be a minimum. And then you connect your dots. Okay? And I should have said this earlier, but this is a periodic function. Periodic means it just keeps doing the same thing over and over again. Okay? All right. Any questions? All right. Hope you've enjoyed the video. See you next time. Stay above the line.